Chapter 5. Data Types and Signal Flow. Connector Types Explained. SynthMaker supports over 30 different types of data. Each type has its own connector with a unique symbol for easy recognition. Although there are many different types of data, they all fall into one of two different categories: stream or triggered. Stream data covers all digital audio and control signals. These signals are fluctuating at sampling rate, and so any components which process them will also perform calculations at sampling rate. Components that process stream data are where all the digital signal processing occurs. Trigger data works in a completely different way. Where stream data is continuously flowing, triggered data only flows in response to some event. Usually the event is a user interaction, or data arriving from some external source like MIDI, or a timer. Note that in the vast majority of cases data flows from left to right. By this we mean from output connector to input connector. This is true for all stream data, but there are a few exceptions with some of the triggered data types. Stream data. Poly and mono. There are two main stream data types that you need to be aware of: poly and mono. These are very similar, but they differ in two very important ways. The first difference is in the number of signals they can carry simultaneously. Poly connectors can carry many digital signals at one time, whereas mono connectors only carry one. The second difference is that a set of mono components connected together to form what we call a mono section always has data flowing through it. Once connected on the right to a direct sound out or ASIO out component, or when inside an exported plugin used in the host, a mono section will run constantly even if there is a zero-level signal passing through. In contrast, a poly section only uses processing when there are signals passing through it. The number of signals is determined by the number of nodes being played. If there are no signals, then there is no CPU hit. However, when there are one or more nodes playing, you'll get proportional usage of CPU for each signal generated, although because of the way SynthMaker uses SSE, you only get an increase on every fourth node. Poly connector represents multi-channel audio signals. Each channel is an independent, fast-moving stream of floating point data that fluctuates at sampling rate. The data is multi-channel because there is one channel for each node that you play. Mono connector, also a fast-moving stream of floating point data that fluctuates at sampling rate. However, there is only one channel, and provided it is connected to a sound output component like direct sound out, it is always active. When to use poly or mono? You would use a combination of poly components, a poly section, to model the polyphonic part of a synth. With the poly section you can generate separate audio signals for each voice or note that you play. You can then merge the poly signals to mono and have a mono section where you would apply effects to the combined signal as a whole. Poly and mono connectors allow you to easily see what kind of data is flowing through different parts of your schematic. This is important because when adding to your schematic you need to know whether the processing you introduce will be applied cumulatively for each voice, poly, or constantly for one signal, mono. Stream connectors. You can create modules that can be used in a poly or a mono section by using stream connectors. These look like dark gray versions of the poly connector. Stream connector: when the stream output connector is linked to a poly or mono connector, it instantly picks up that type. The type change then flows from left to right back through any other stream connectors, changing them to the new type accordingly. Poly and mono sections. To get any data to flow through a poly or mono section, you have to connect it up correctly. In most cases you will want to use MIDI input from a keyboard or other source to generate notes. You then want each note to make a sound that you can hear. The most common setup would be as shown below. 1. The MIDI to poly module converts incoming MIDI note data into poly signals. 2. The poly section processes the signals. 3. The combiner module then combines the independent poly signals into one mono signal. 4. The mono section applies processing to the result. 5. The final signal is sent to your sound card via a direct sound out or ASIO out component within SynthMaker, or via the host audio setup diffuse within a plugin. Note: if you don't have direct sound out or ASIO out component, no audio processing will be performed. A complete, usable poly section always starts with the MIDI to poly module and ends with the combiner module. The only exception is if you are using a signal analyzer to look at the output from a poly section. You can have a mono section without a poly section. This is what you would have if you were creating an effect that performs some DSP on an incoming signal. However, if you want to hear anything, you have to connect a mono section to an output device via a direct sound out or ASIO out component. Boolean connectors. There are Boolean equivalents of the poly, mono and stream data types. They are only seen on a few components, most notably the poly and mono comparison components. The MIDI to poly module has a poly Boolean output which shifts from false to true when a note is played, and can therefore be used as a gate signal. Poly Boolean. Multi-channel mask, one mask for each note playing. Mono Boolean. Single channel mask, constantly running. Stream Boolean. Poly-int. The poly-int data type is the integer equivalent of the poly type. It is used only in the graph to poly to allow sample rate indexing of float arrays. Polyint. Multi-channel integer, one channel for each note playing. SSE. If a CPU supports SSE, then it has a set of instructions built in that allow mathematical operations to be performed on multiple sets of data at the same time. SynthMaker makes full use of this when processing stream data. The result is that you can effectively play up to 4 notes at the same time for the same CPU cost as just one. Mono 4. If you really want to get the best performance out of the mono section, then you need to consider using the mono 4 data type. It's not always possible to use this, but when you can, it makes a huge difference to performance. Mono sections only have one sound process. Because SynthMaker uses SSE, this process could be doing 4 times the work for the same CPU cost. To take advantage of this, we have the pack and unpack components. These allow you to literally pack 4 mono channels into one mono 4 stream. Mono 4. 4 mono signals processed as one. Performance. To help you gauge the effect of changes to the stream parts of your schematic, we have a CPU meter. This can be found on the right side of the status bar at the bottom of the application window. The CPU meter is very basic. It only measures CPU performance of the stream sections. GUI performance is not measured. Triggered data. How it works. Triggered data only flows through a schematic when an event occurs that triggers a change. Until this happens, sections of triggered data remain in a steady state. When an event does occur, a message called a trigger is sent out through output connectors on one or more components. The trigger flows through the links until it reaches another component. That component then assesses whether its state would be affected. Any necessary recalculations are then performed, and a trigger is sent out through any output connectors on that component. The process continues, creating a waterfall effect through the schematic. The example below shows a very simple example of 2 numbers being added together. When you type in the float component, this results in one of the events that we've been talking about, and a trigger flurry begins. Note that during the recalculation part, a component may ask the components that provide values to its inputs for their latest values. This in itself can cause a flurry of messages to the left. Triggered data is easily identified by color, as all connectors that carry triggered data are green. There are 5 main triggered data types.